Welcome to the channel. I haven't been able to upload any videos in the last 2 weeks. The shop has been kind of busy the last month, but I've been doing some tweaks to the housing, some updates to the housing, main housing. This part I 3D printed this week, and I did some modifications to the housing. Um, Now I install brass inserts instead of stainless steel inserts. I think these brass inserts work better with the screws. They don't bind too much. The other inserts that I installed before, they were stainless steel as well, but sometimes they bind to the screws. And these brass inserts, they don't bind to the stainless steel screws. One more modifications that I did to this new housing is these four holes. The ones that hold the bottom housing for the optical sensor and the main board. I also change them to to brass inserts. I was installing stainless steel inserts also on these four holes, and I went through all the way through from the bottom up to the surface, so I can give a clearance to the when I'm screwing the tightening the screws. They can go all the way up through this hole. These four holes are not true; they're not blind holes. I think this works better, and one more modification that I did to this housing is this flange or wall or roof. I did some improvements to this lip. I was getting some. The printer was having a hard time printing this lip, so I did a chamfer instead of a fillet, and it's been working better. This is the latest design on this housing for the 3 inches and a half phenolic ball. And I also have 3D printed some PG buttons with a different with this yellow color. This is the same housing as this one. Once I have the 3D printed set up, I just remove the the finished part and load another plate and start printing again. That's what I'm able to print 2 or 3 housings in 2 or 3 days. These housings take around 22 hours to print, so it takes a long time to print. But they're nice. They're beautiful. And this is a finished unit. I like the color, the black color, PG, with the ivory ball and those kind of yellow, maybe amber color, PG buttons. They look really nice on this with this black color and the ivory phenolic resin ball. I haven't received the um, the main board and the sensors from the company. I'm still waiting on the sensors and the boards. But I just wanted to uh, give you an update. I just wanted to give you guys an update on this new build. I'm building more of these things, more houses on this dimension with this size ball, but with different um, material and different color buttons. They have the same switches, the Cherry MX Silver Speed switches, and they 3D printed in PG now. The only part right now that is 3D printed in PLA is this gray part. It's part of the bottom housing where the sensor goes and the main board. The rest is 3D printed now in PG. And this thing moves really nice. It's nice and heavy for big hands. I'll keep you posted when I receive the main board and the sensors. I need to solder the sensors to the boards. They don't come with the sensor already soldered to the board. So that's one thing I have to do. I have to solder the sensor to the board, and then I gotta do the wiring for the buttons from the main board up to each button. And now the cool thing about this these new housings that I'm 3D printing is the fact that you can remove the cover and remove the buttons individually. That's what I wanted to do since from the beginning. Now the cover, you can remove all the buttons. They're not attached permanently to the top cover. You can just detach the top cover from the connector from the coming from the main board at the bottom of the trackball, and you can just push it, and you can remove all the buttons. It's very easy. I work on this design for many weeks until I get them right. It's almost effortless to remove the buttons now. Before I had everything in one piece, but I didn't want to go through 3D. I didn't want to go and 3D print the whole cover just to replace a bad switch. So this way, this top cover, it doesn't have to be replaced. It can stay there forever. The only thing that you need to replace in case something happens is the button itself, the cables, the socket, or the keycap, or you wanna remove the keycap, just push it out, and you can replace now the switches. You can swap switches now this way. It's a very nice design. It took me weeks, probably months, like 2 months to finish this design. But now it's working. Now I can if something goes bad with this switch, I just remove the cap, grab another switch, install the cap, install the switch on the pocket of the button, push it in, and these whole switches are the same. They all the same, so they can be anywhere as long as cables are connected to the right buttons. They're swappable. You don't they don't go in any particular way. Just make sure when you install the cables coming from the bottom of the sensor in the board, attach and close the to the closest button you have to the bottom of the main housing and the bottom housing. It's really easy. Just put them in and push it. There's one. Just make sure the socket stays away from the flange and the ball, so you have more room for the wiring. And now it's pretty easy to change the buttons. Just take them out. Something goes bad, replace the switch or replace the wires, and it's a piece of cake. Put it back. Put the three screws. And these screws, they don't have to be tight. They just snug. They don't need you don't need to use power tools. It's better to use hand tools. So you don't strip the inserts out of the cover, or the inserts from the bottom, the middle housing. I never use any power tool to assemble this thing. It's just by hand. They don't have to be tight, just snug. The same goes with the bottom screws. They just snug. They're not tight. These screws, the four screws on the bottom, they're there just to hold the bottom housing where you install the main board and the optical sensor. And these three on top, they just there to hold the top cover. The whole unit is actually held by two aluminum plates and 4/4 20 heavy duty machine screws. So those plates are the ones holding the whole thing together. There's no strain on the housing, the cover, or the bottom housing. The aluminum plate on top and the aluminum plate on the bottom, those two aluminum plates are the ones holding the whole weight, and the four 1/4 20 screws to be installed on top of the desk, or on top of the desk or table or machinery, whatever. That's it for tonight. I'll continue working on other projects that I have on this unit, different uh, mechanical movement, especially the ball bearings and German made BTUs. I'm gonna do two more designs. One with the German BTUs. This one has the BTUs made in China. They were fine. I don't see any issues with those BTUs. Uh, if anything, I'm saving a little bit of money using these BTUs made in China. But I'm gonna do another design with the same thing, but I'm gonna install instead of the economical BTUs, I'm gonna use the premium BTUs. The BTUs I showed you on one of the previous videos. On the previous videos, the German, the Rexroth BTUs. I gotta redesign the main housing to accommodate those three German-made BTUs, and then I'm gonna do another design. Everything the same, but I'm gonna do another design with a skateboard ball bearings. My trackball on my desk is using those skateboard ball bearings. It's been working fine, but I wanna try to use. I wanna make at least one trackball with skateboard bearings to see what is the difference between the the ball bearings, the economical BTUs, and the expensive Germany made or German made BTUs. That's coming in a future video, probably a few videos when I have time. Right now, the shop we're really busy. That's why I haven't uploaded any videos. I'm gonna try to upload this probably tomorrow. Another video that I have from 2 weeks ago, 2 weeks ago that I haven't been able to edit and upload. But I'm gonna try to upload this one and the other one this week. That's it for now. Comment, like, and subscribe. And thanks for watching. See you in the next one.